What if I told you that 1,300 Earths could fit inside one planet, and millions could fit into another star? Prepare to have your mind blown. Today we're diving into one of the most mind-bending questions about our solar system. How many Earths could fit inside each planet? Not just roughly, but with real simulations and real astronomical data you can visualize. We'll start small, the tiniest rocky worlds, and work up to the colossal giants. Then compare them all in ways that will make your jaw drop. By the end of this journey, you'll understand exactly how small our home really is compared to the giants of space, and why these comparisons aren't just numbers, but clues to how planets form and evolve. To start, this video isn't about how heavy planets are, it's about volume, or how much three-dimensional space they take up. Astronomers measure planet size by the space inside the sphere, not just diameter or radius. And when you compare volumes, things get wild fast. One Earth has a volume of about 1.08 trillion cubic kilometers. Using that as our baseline allows us to compare how many Earths could fit inside another world's volume if they were spherical and tightly packed, though real packing would leave gaps. Let's start with the intimate neighbors. Mercury, the smallest planet in our solar system, is barely bigger than our Moon. It could hold roughly 0.055 Earths, meaning Mercury is less than 6% the volume of Earth. Mars, our dusty red neighbor, might be slightly bigger than 1/10 of Earth's volume. You'd need about 6 to 7 Mars-sized worlds to equal one Earth. Venus comes in close, about 0.85 Earths, nearly the same size as Earth, but still noticeably smaller in volume. This puts into perspective how Earth, Venus, Mars, and Mercury are all part of a family of rocky worlds, but each has its own unique size identity. Now we reach the giants. Jupiter. The king Jupiter is not just the largest planet, it's a monster. Its diameter is more than 11 times greater than Earth's, but because volume increases with the cube of the radius, its actual capacity is enormous. According to scientific volume comparisons, approximately 1,300 Earths could fit inside Jupiter. Imagine stacking Earths like marbles after you put 1,000. You're still only a fraction of the way through Jupiter's interior. Why? Because Jupiter isn't a solid rock, it's mainly hydrogen and helium gas compressed into a huge sphere. Saturn, rings and more. Next up is Saturn, visually famous for its rings but also massive in volume. Saturn's volume is about 760 times that of Earth, meaning 760 Earths could fit inside it. Even though it's similar in diameter to Jupiter, Saturn is less dense. That's why it could float in water if you had a bath big enough. A fun aside, that's scientific folklore based on density comparisons. Uranus and Neptune, the ice giants. Finally, we reach the more distant giants. Uranus could hold roughly 63 Earths. Neptune is slightly smaller in volume, fitting around 58 Earths. These worlds are often called ice giants, because their interiors contain substantial amounts of water, ammonia, and methane ices mixed with gases. Though not as massive as Saturn or Jupiter, their size is still vastly greater than Earth's. But here's the twist that most people don't realize. Volume isn't everything. Just because a planet has room for many Earths doesn't mean it would behave the same. Two planets might have similar volumes, but totally different compositions, densities, and internal structures. For example, Jupiter and Saturn could hold hundreds to thousands of Earths, but they're mostly gas, not solid ground you could walk on. Mars is small in volume, but its geological history tells a story of water and lost atmosphere that Earth still hasn't fully deciphered. So here's the challenge. What does volume really tell us about a planet? And what doesn't it tell us? That's what we'll explore next. Let's break that challenge down by asking, Does a bigger volume mean a stronger world? Not always. For instance, Earth and Venus are similar in size and volume, but Venus has a runaway greenhouse atmosphere hotter than a pizza oven. In contrast, Jupiter's huge volume doesn't mean Earth's inside it would survive, because the pressure deep inside the gas giant would crush any solid planet into oblivion. Then consider Uranus and Neptune's similar volumes, but extremely different internal heat flows. Uranus barely emits heat, yet Neptune emits more energy than it receives from the Sun. So when we talk about how many Earths could fit inside Jupiter, that number is a volume comparison, not a life comparison or habitability measure. It's a way to visualize scale, not an invitation to fill Jupiter with Earths. Now, imagine this. If we could fill each planet with Earth-sized spheres, from smallest to largest, the scale would look something like this. Mercury barely holds a fraction of one Earth. Mars fits about a tenth of an Earth. Venus, almost one Earth, but smaller. Earth, exactly one, obvious. Uranus and Neptune, dozens of Earths. Saturn, hundreds. Jupiter, more than 1,000. Let that sink in. The largest planet in our system is over 1,000 times bigger than Earth in volume, not diameter. So, what did we learn? Volume scale in space is not intuitive. Even planets that look close in size can hold wildly different amounts of Earths. And volume comparisons are one of the best ways to visualize the true scale of worlds beyond our own. From the tiny rocky world of Mercury to the gargantuan gas giant Jupiter, each planet tells a different story, not just in size, but in how it formed and evolved over billions of years. And if you enjoyed the video, make sure to like and subscribe, and check out the channel to find more amazing and new videos.